Okay, let's talk about completing the square. Grunt, I hear you grunting. I know it's not your favorite. It's a shame because it's a wonderful way to solve for quadratics. If I give you x squared minus 6x plus 10 equals 0. Or let's say I give you the function y equals x squared minus 6x plus 10 and ask you to find the roots. Or maybe I say x-intercepts if I know they're going to be real roots. Hopefully you recognize, hey, I'll factor. That's the first thing you should look for. GCF. If there's a GCF, take that out. There's not. So with a quadratic, you got a square term, you got a first degree term. Are there factors of 10 that add up to negative 6? I don't think so. So if you're going to use the completing the square, we're going to subtract 10 from both sides. Minus 10 here, minus 10 here. Now what we need to memorize is b over 2 squared. b over 2 squared is the thing you've got to memorize, okay? So in this case, my b value is negative 6, so I've got a negative 6 over 2 quantity squared. You recognize that as negative 3 squared, or 9. We're going to add 9 to both sides. This is the keystone that allows us to complete this square. And by a square, I mean a perfect square trinomial. The left-hand side, I'm going to have something inside quantity squared, and that's all I have on the left. You always put an x here. Square root of x squared is x. Now we don't take square root of 9 because then you might do plus 3, and that's not right because of the sign. I teach my students, what you see on the inside here, that's what you put here. Negative 6 divided by 2 is negative 3. And negative 10 plus 9 is negative 1. You might have expected a positive number. Often we see positive numbers. And then we teach you about the wonders of the imaginaries, the unreal world. We take the square root of both sides because we want to get x by itself. Got to remove the square first. So we get x minus 3 equals, square root of both sides requires a plus or minus. Whenever you take an even root of both sides of an equation, we want a plus or minus. The square root of negative 1, by definition, is I. Hopefully you know that by now. One more step, add 3 to both sides. This is going to be a complex number, so I put the 3 in front. That's the typical way, typical form, and I like set notation. 3 plus or minus I. 3 plus I is an answer. 3 minus I is an answer. You could plug it in and check, but I wouldn't want to do that. But I want you to know this is a parabola. It goes up. The leading coefficient is a positive 1, so it does kind of look like this. But down here somewhere is the x-axis. It doesn't actually go through because the x-intercepts have to be real. These are unreal or non-real. These are imaginary. So it kind of looks like this. And we see a lot of parabolas that don't actually cross through the x-axis. So this is something like this. This is completing the square. Students don't like it. I get it. I like completing the square. I think it's elegant. But I know some students don't prefer it if, say, this number's odd. I kind of feel the same way. Let me just change this to minus 5x. If you move that negative 10 over, x squared minus 5x, I could write it out like this, which is a good idea. Negative 10 is over here. And now you got to think about, okay, b over 2 quantity squared, that's negative 5 over 2, which means I'm going to have negative 5 over 2 here. Okay, quantity squared. And then here, negative 5 over 2 times itself is plus 25 fourths, and this scares students like, man, I got to remember common denominators, and ew, I don't like doing that. And all right. But there's a reason us teachers insist you learn completing the square. You might look at this and think, hey, I'm just going to use the quadratic formula. I have sang Pop Goes the Weasel so many times, I never want to hear the song again, but I've memorized that. And students don't respect completing the square the way they should. I want to help you with that today. Instead of looking at x squared minus 6x plus 10, let's take something very, very universal. I'm going to give you every possible quadratic. Here we go. What is A? Could be anything. B, same thing. C, I don't know. Could be anything. This is like the universal form in standard form for any quadratic. We can use completing the square on this. Now what are we going to get? You got to remember with completing the square, you got to move the constant over. That would be my first step. Ax squared plus bx equals negative c. And then something we didn't have to worry about in the prior example I gave you, we can't have a leading coefficient of anything other than 1. So I'm going to divide every term, both sides, every term by a. These go away. I'm going to get something that's a little bit ugly before I even find that keystone. But follow along. I hope you see where I'm going on this. I've got x squared plus b over ax equals negative c over a. And now the goal is to find that keystone. We're going to take this number and square it. So I've got this b over a. Oh, I shouldn't say squared. I'm going to divide by 2, which is the same thing as putting a 2 down here. And then I'm going to square it. I believe this gives us b squared over 4, what did I say? A squared. There we go. B squared over 4a squared. I'm going to add this to both sides, okay? So here, however you write it, doesn't really matter. What's important is that on the side you show this. It's going to be easier for you to show the perfect square trinomial, okay? Here, perfect square trinomial, there goes the x. What was inside was a positive b over 2a, so plus b over 2a. And over here, yep, I'm asking you to combine two fractions with uncommon denominators. This one's got to become 4a squared, so let's see. Negative c over a, let's multiply top and bottom by 4. Let's make this a squared, so I'm going to multiply the bottom by a, and let me just quickly make that an a. Negative 4ac over 4a squared. Now, combine this and this. B squared is the positive, I'll put that in front. B squared minus 4ac over 4a squared. Some of this looks familiar, right? Okay, maybe the word discriminant is coming to mind. But let's continue. I've got some that's squared, and I want to get x by itself. Square root of both sides. X plus b over 2a equals, and now I'm taking the square root of a fraction. Square root of b squared minus 4ac, can't clean that up. Divided by square root of 4a squared, that's a square, so I can just make it 2a on the bottom. Square root of b squared minus 4ac. The only thing I'm forgetting right now is because I took an even root of both sides, I want a plus or minus. Are you seeing where I'm going? I've only got one more step. I need to subtract b over 2a from both sides. Here's my x value. The plus or minus, we usually don't like it in front. We're going to put that negative b in front. So negative b plus or minus the square root. Do you hear the song in your head one more time? 4ac all over 2a. There it is. There's your quadratic formula. And we got it from completing the square. Completing the square is your friend. Please respect it.